Hi everybody, welcome to Arts Innovation, Artademia, Learning Redesigned. Artademia is based on the concept that art equals math equals music. We talked about that in the intro. Now I'd like to walk you through exactly what the math and art and music looks like. So let's get started with the art code. The art code is a squared plus b squared equals c squared. You know it as the Pythagorean theorem. But this is actually the Pythagorean proof of the theorem, and it's based on the fact that not only do the 3 squared plus 4 squared equals 5 squared, but the remaining empty spaces, symbolized by the triangles, also equal each other. So it's a double proof, a geometric proof, and it's based on this math, which is 3 squared plus 4 squared equals 5 squared. And here you can see that they're not using triangles, but again, by color coding the squares, you can actually count up what equals what in both the 3 and 4 and the 5 squares. You can see that both squares are actually 7 squared. It's kind of overlooked, but that kind of plays into this whole thing of learning more with the visuals than you learned from the algebraic formula. So let's take a look at how that translates into music. Here's the music code. Now you wouldn't know this or even think about this if you were not a musician, and if you were a musician and you didn't know the math and you just used the chromatic scale and put your fingers on the frets on your guitar where you're supposed to, it would not make any sense to you. But basically what this is in music, at A440 for example, you've got c squared plus f squared equals a squared, which basically means that in the way that the chromatic scale is used, it alters the ancient Pythagorean tuning, which is, if you look at the number 40 there, which is A, it's 40 times 11 is 440. 24 times 11 is 264, and 32 times 11 is 352. So if you square all those numbers, you'll see that they are completely equal, and you will do that with every single key in music. The key is always the one that's divided by 4. So this is the key of F, F-A-C. So you got 4, 5, 6, or 3, 4, 5, inverted. Either way, it's the same, and you can construct a harmony in this manner. So let's take a look at how that translates into another code, which gets us into the advanced geometry. 3 cubed plus 4 cubed plus 5 cubed equals 6 cubed. And what that means is you've got 6 cubed is actually 216. And in hertz, you can see how you've got this musical structure at 3 squared plus 4 squared equals 5 squared, or in this case 324 squared plus 432 squared plus equals 540 squared. So what happens here is you've got the same interval in hertz, and so you've got 3 times 108, 4 times 108 equals 5 times 108. So you can actually turn this into 3D. In other words, instead of just being a square, it can be turned into a cube. And then you have this formula which will do that. If we take a look at how that happens, we call it geometrics. What happens is you can fold 2 triangles into an octahedron, as we can see here. And then around that octahedron, we can fold triangles into tetrahedra and put them all around there, and you end up with a cube. So we actually pulled the square into a 3-dimensional cube that has half the volume of a regular cube because of the way the spaces are left inside there. This seems complicated, but I've actually taught this to kindergartners, how to fold these together and make these shapes without even saying a word to them. You can just throw them on the floor, show them what I had done, taping them together, and they will take the tape and fold them together. They don't have to learn the formula. They don't have to learn what's going on. They will do that later. But in the meantime, as kindergartners, they learn geometry without even having to explain it to them. The next one shows how this geometry turns into sound. It's called cymatics. It's a visualization of sound, and these are actually cymatic shapes in water of the particular vowels sung by a female singer. You can find these on cymatics.org or cymatics.com. they make a cymoscope. I believe cymoscope is the way that they developed these visuals. So these are actual photographs of the visuals that are created. They're not flat, they're actually spherical, but this is the representation as though it was a cross section. So these are the sounds for A, E, I, O, and U. The vowels actually change based on the shape of your mouth. But by singing these particular vowels, you can change the patterns of the sounds, even though they might be in the same or similar wavelength. But it's something you should experiment with, and something I find very fascinating in terms of the study of geometry and how it relates to sound. As a result of that, 30 years ago I invented my first guitar, and I discovered that you can change the position of the frets, and you can change the tuning so that you don't have to have it tuned typically. A typical tuning is E, A, D, G, B, E. I've retuned everything into what they call sacred tuning, D, F, A, C, E, G, because it's alternating major and minor thirds. Now this won't make any sense to you if you're not a musician, but I've actually put the math over here so you can see that at the bridge, you're tuning these. I'm tuning D to 288, F to 360, A to 432, C to 540. It's actually a C sharp, E to 648, and G to 792. These are the intervals in between. So what you can see is you can, by mathematically doing this and tuning everything, then what you have is a perfect harmonic structure. And we'll get into this later, but the difference between this and normal tunings is when you add these together, everything adds up to the octave of C. So when you put these pairs together, you're going to see that they add up to 1080 if you put this together correctly. For example, you can see that 648 and 432 are 1080, and 288, 792 are 1080. A doesn't have its partner over here, which would be the octave of A, which would be 864, which would be actually 1296. So you can see that you add these things together and they come into different harmonic structures. And there's a lot of different ways that you can do this. So we'll get into that more into the Art Tech section. Anyway, think about this and see how this actually fits together, and see how we can take these particular subjects and put them into all the other subjects that you're studying or teaching. See you next time.